Machine learning questions that interviewers really care about. How much profit can you expect to make on average every 6 games? Answer: according to the given information, you can expect to make a profit of $30 every 6 games. This means that if you play 6 games, you can expect to earn $30 more than you would have if you didn't play those games. This is the average profit you can expect to make over a period of 6 games. Write a SQL query to make recommendations using pages that your friends have liked when it should not recommend pages that you have liked. Answer: the query should join the table of users and their friends with a table of users and their liked pages, and then use a subquery to exclude the pages that the user has already liked. The query should also group the results by user and page, and then use a ranking function to rank the pages by the number of friends who have liked them. The final query should return the top ranked pages for each user. Here is the SQL query. Select username, page name, count asterisk as frequency. From users friends off. Join users liked pages up on off friend ID equals up user ID. Join pages P on up page ID equals P page ID. Where F user ID equals up user ID. Group by username P page name. Order by frequency desk. Note: the above query assumes that the tables are named as users friends, users like pages, and pages. The actual table names may vary based on the database schema. Also, the query does not consider the case where a user has liked a page and then unliked it, as the query only considers the current state of the liked pages. A more complex query would be required to handle this case. What type of algorithm is used to generate recommendations like people who did this also bought this on a website? Answer: collaborative filtering is the algorithm that propels this type of recommendation. It compares users' activities on a website and recommends similar actions to users with similar interests or behavior. This means that if a user has shown interest in a particular product or category, the algorithm will suggest other products or categories that users with similar interests have also shown interest in. This approach helps to identify patterns and relationships between users and items and provides personalized recommendations to each user. You're watching this to grow. So take it one step further, challenge yourself at MLQsCafé.com. Practice real questions, see where you stand, and keep getting better. One quiz at a time. Now, let's get back to the next question. What would you do if the model you have trained has a high variance and low bias? Answer: if the model has high variance and low bias, you would use regularization techniques to reduce the high variance and bagging algorithm to reduce the low bias. Regularization techniques, such as low and alto regularization, can help to reduce the high variance by penalizing complex models. On the other hand, bagging algorithm can help to reduce the low bias by creating multiple models with different subsets of the data and combining their predictions. This can help to reduce the overfitting caused by the low bias and improve the overall performance of the model. What is machine learning, and how does it differ from traditional programming? Answer: machine learning (ML) is a type of computer science where algorithms are designed to learn from data and make predictions or decisions without being explicitly programmed for each task. This is different from traditional programming, where rules and logic are explicitly coded. In ML, the model identifies patterns from the data and adapts its behavior accordingly, allowing it to improve its performance over time. This means that ML models can learn from experience and make decisions that are more accurate and effective than traditional programming. What are the different types of machine learning? Answer: machine learning has 3 main types: supervised learning, unsupervised learning, and reinforcement learning. Supervised learning involves training a model using labeled data to make predictions. Unsupervised learning involves learning patterns from unlabeled data to group or cluster information. Reinforcement learning involves learning by interacting with the environment and receiving feedback in the form of rewards or penalties. These types of machine learning are used to solve different problems and make predictions in various fields. What are the different subsets of data used in machine learning, and what are their purposes? Answer: in machine learning, three main subsets of data are used to train and evaluate a model: the training set, validation set, and test set. The training set is used to train a model, where the model learns from the data to make predictions. The validation set is used to fine-tune the model's hyperparameters, which are the settings that affect the model's performance. This helps to prevent overfitting, which is when the model becomes too specialized to the training data and fails to generalize well to new data. The test set is a separate data set used to evaluate the final model's performance, giving an unbiased estimate of how well the model will perform on new, unseen data. By using these three subsets of data, machine learning models can be trained and evaluated effectively, leading to better performance and more accurate predictions. What is the main difference between classification and regression in machine learning? Answer: the main difference between classification and regression is the type of output they produce. Classification models predict a category or a class label, such as spam or not spam, whereas regression models predict a continuous value, such as the price of a house. This difference affects the type of data used to train the model, the evaluation metrics used to measure performance, and the techniques used to make predictions. What is logistic regression? Answer: logistic regression is a type of classification algorithm used to predict binary outcomes such as 0 or 1 by modeling the probability of an event occurring using a logistic function, also known as a sigmoid function. This algorithm is commonly used in machine learning and data analysis to predict the likelihood of a specific outcome or event, and is particularly useful when dealing with binary data. What are overfitting and underfitting, and how do they affect a model's performance? Answer: overfitting occurs when a model learns too much detail from the training data, which can lead to poor performance on new, unseen data. This is because the model has become too specialized to the specific training data and fails to generalize well to new situations. On the other hand, underfitting happens where a model is too simple and fails to capture the underlying patterns in the data. This can result in the model being unable to make accurate predictions or classify data correctly. Both overfitting and underfitting can significantly impact a model's performance, making it important to strike a balance between model complexity and training data size to achieve optimal results. How do you handle missing or corrupted data in a dataset? Answer: when dealing with a dataset that contains missing or corrupted data, there are several methods to handle it. One common approach is to remove rows with missing values, which can be done by filtering out the rows with missing values. Another method is to impute missing values using statistical methods such as mean, median, or mode, which can help to fill in the missing values. Additionally, some algorithms are designed to handle missing data directly, allowing you to analyze the data without having to preprocess it. The choice of method depends on the specific problem and the type of data being analyzed. What is feature engineering, and why is it important in machine learning? Answer: feature engineering is the process of creating new features or modifying existing ones to improve a model's performance. This is important because well-engineered features help the model understand patterns better, leading to more accurate predictions. By transforming raw data into more informative features, feature engineering enables the model to learn more effectively from the data, resulting in better decision-making and improved outcomes. What is the difference between data normalization and standardization, and how do they scale data? Answer: data normalization scales data to a range of 0, 1, which means that all values are transformed to be between 0 and 1. This is done to ensure that all features have the same range, which can be helpful for certain machine learning algorithms. On the other hand, data standardization scales data to have a mean of 0 and a standard deviation of 1. This is done to reduce the effect of features with large ranges on the model and to make it easier to compare the importance of different features. In other words, normalization is used to rescale the data, while standardization is used to shift and scale the data to have a specific mean and standard deviation. What techniques help models converge faster and perform better? Answer: regularization techniques, such as low and NLP regularization and early stopping, help models converge faster and perform better by reducing overfitting and preventing the model from getting stuck in local minima. These techniques allow the model to generalize better to new, unseen data. Regularization adds a penalty term to the loss function to discourage large waits, while early stopping stops training when the model's performance on the validation set starts to degrade, preventing overfitting. This results in a more robust and accurate model. What is supervised learning? Answer: supervised learning is a type of machine learning where a model is trained on labeled data, which means that each input is paired with the corresponding output. The model learns to make predictions for new, unseen data by identifying patterns and relationships between the inputs and outputs. This type of learning is commonly used for tasks such as regression and classification, where the goal is to predict a specific outcome or category. For example, in image classification, a supervised learning model would be trained on a dataset of labeled images, where each image is paired with a label indicating what the image depicts. The model would then use this training data to learn how to classify new and seen images into the correct categories. What is a decision tree, and how does it work in machine learning? Answer: a decision tree is a type of machine learning model that uses a tree-like structure to classify data or make predictions. It works by splitting the data into smaller subsets based on the values of certain features, with each split representing a decision point. The model starts at the root node and follows the path of decisions to a leaf node, where the final prediction or classification is made. This process is repeated for each sample in the dataset, allowing the model to make predictions or classify new data points. The decision tree is a powerful tool for identifying patterns and relationships in data, and is often used in combination with other machine learning algorithms to improve their accuracy. What is the k-nearest neighbors KNN algorithm, and how does it classify data points? Answer: the k-nearest neighbors KNN algorithm is a simple classification method that predicts the category of a new data point based on the categories of its k-nearest neighbors. It works by calculating the distance between the new data point and each data point in the training dataset. The distance can be measured using various methods such as Euclidean distance. Then it assigns the category of the majority class among the k-nearest neighbors to the new data point. This approach is simple yet effective, and is often used in machine learning applications where the data is not well understood or when the number of features is high. What is the naive Bayes classifier, and why is it called naive? Answer: the naive Bayes classifier is a type of machine learning algorithm that uses Bayes' theorem to classify data. It's called naive because it assumes that all features or attributes of the data are independent of each other, which is often not the case in real-life data. This simplifying assumption makes the algorithm easier to implement and understand, but it can also lead to less accurate results if the features are actually correlated. Despite this limitation, the naive Bayes classifier is widely used for tasks like spam detection and text classification due to its simplicity and effectiveness. What is a recommendation system, and how does it work? Answer: a recommendation system is a technology that suggests products or content to users based on their behavior and preferences. It works by using techniques like collaborative filtering and content-based filtering to identify patterns in user behavior and provide personalized recommendations. Collaborative filtering suggests items similar to those liked by similar users, while content-based filtering suggests items similar to what the user has interacted with before. This helps users discover new products or content that they may be interested in, and businesses can use it to increase sales and customer engagement. What is deep learning? Answer: deep learning is a type of machine learning that uses artificial neural networks with many layers to analyze and recognize complex patterns in data. This approach is particularly effective for tasks such as image and speech recognition, as it allows the network to learn and improve its performance over time. In deep learning, each layer processes and refines the information, allowing the network to extract increasingly abstract and meaningful features from the data. This enables deep learning models to achieve state-of-the-art performance in many applications, including self-driving cars, medical diagnosis, and natural language processing. What are some real-life applications of supervised learning? Answer: supervised learning has many real-life applications where it is used to classify or predict outcomes based on labeled data. Some examples include spam detection, where algorithms identify spam emails, fraud detection, where transactions are flagged as suspicious, and medical diagnosis, where diseases are classified based on medical records. In these applications, supervised learning helps machines learn from labeled data to make accurate predictions and improve decision-making. This technology is widely used in various industries, including finance, healthcare, and marketing, to name a few. By using supervised learning, machines can learn from past experiences and make informed decisions, leading to improved accuracy and efficiency. What is the clustering algorithm and how does it group data points? Answer: the clustering algorithm is a method that groups data points based on their similarities. It does this by partitioning the data into clusters, where each point belongs to the cluster with the nearest mean. This means that data points that are similar to each other are grouped together, and those that are different are separated into different clusters. The k-means algorithm is an example of a clustering algorithm, where the data is divided into k-clusters based on the nearest mean. This helps to identify patterns and relationships in the data and can be used in a variety of applications such as customer segmentation, image classification, and data compression. What is a confusion matrix, and how is it used to evaluate the performance of a classification model? Answer: a confusion matrix is a table that helps evaluate the performance of a classification model by showing the true positives, true negatives, false positives, and false negatives. It is used to calculate metrics like accuracy, precision, and recall, which provide insights into the model's performance. By analyzing the confusion matrix, developers can identify areas where the model is making mistakes and improve its performance by adjusting the model's parameters or adding more data. This helps ensure that the model is accurate and reliable in its predictions. Define precision, recall, and phone score. Answer: precision is the ratio of correctly predicted positive observations to the total predicted positives. It measures how accurate the model is in identifying actual positive instances. Recall, on the other hand, is the ratio of correctly predicted positive observations to all actual positives. It measures how well the model is at identifying all actual positive instances. The phone score is the harmonic mean of precision and recall, which balances the two. It provides a single score that takes into account both the accuracy and completeness of the model's predictions. The phone score is often used to evaluate the performance of machine learning models, especially in cases where both precision and recall are important. What is the difference between accuracy and precision in prediction models? Answer: accuracy measures the overall correctness of predictions, including both positive and negative predictions. On the other hand, precision focuses on the correctness of positive predictions, specifically how many true positives are among all positive predictions made. In other words, accuracy looks at the big picture while precision zooms in on the positive predictions. This difference is important in understanding how well a model is performing and making informed decisions. What is the ROC-AUC curve? Answer: the ROC-AUC curve is a graphical representation that shows the relationship between the true positive rate sensitivity and the false positive rate of a model. It plots the true positive rate against the false positive rate at different thresholds. The area under the curve AUC measures the overall performance of the model, with a higher AUC indicating a better model. The ROC-AUC curve is commonly used in machine learning and data science to evaluate the performance of classification models. What are type I and type Roman II errors in the context of model predictions, and how do they differ? Answer: type I errors, also known as false positives, occur when a model incorrectly predicts a positive outcome. This means that the model identifies a non-existent positive outcome, leading to unnecessary actions or decisions. On the other hand, type Roman II errors, also known as false negatives, occur when the model misses a positive outcome. This means that the model fails to identify an actual positive outcome, leading to missed opportunities or delayed actions. The key difference between the two is that type I errors result in unnecessary actions, while type Roman II errors result in missed opportunities. Understanding the concept of type I and type Roman II errors is crucial in making informed decisions and improving the accuracy of model predictions. What is cross-validation, and why is it important in machine learning? Answer cross-validation is a technique used in machine learning to evaluate the performance of a model by splitting the data into multiple parts, training and testing the model multiple times. This helps to prevent overfitting, which occurs when a model is too complex and only fits the training data well, but not the new unseen data. By using cross-validation, we can ensure that our model generalizes well to new data and provides a more accurate evaluation of its performance. This is important because it allows us to trust the results of our model and make better predictions in real-world scenarios. What is the purpose of data preprocessing, and why is it essential for machine learning models? Answer: data preprocessing is the process of cleaning and preparing raw data before feeding it into a machine learning model. This step is necessary because raw data often contains errors, inconsistencies, and irrelevant information that can negatively impact the model's performance. By handling missing values, scaling features, and encoding categorical variables, data preprocessing ensures that the model receives high-quality data, which enables it to learn effectively and make accurate predictions. Without data preprocessing, machine learning models may produce inaccurate or biased results, which can lead to poor decision-making. Therefore, data preprocessing is a crucial step in the machine learning process that helps to improve the quality of the data and the overall performance of the model. How do you handle imbalanced data sets in machine learning? Answer: handling imbalanced data sets is crucial in machine learning as it can lead to biased models. There are several techniques to handle imbalanced data sets, including resampling, where you oversample the minority class or undersample the majority class. Another approach is to use algorithms like SMOT, which create synthetic samples to balance the dataset. Additionally, you can adjust model metrics focusing on precision, recall, or using the phone score, which is a weighted average of precision and recall. By using these techniques, you can improve the performance of your model on imbalanced datasets. What is dimensionality reduction? Answer: dimensionality reduction is a technique that simplifies a data set by reducing the number of features or dimensions in it. This helps to remove noise, improve model performance, and make it easier to visualize the data. By reducing the number of features, dimensionality reduction makes it possible to identify patterns and relationships in the data that might be difficult to see when dealing with a large number of features. This technique is commonly used in machine learning and data analysis to make complex data more manageable and easier to understand. What is Principal Component Analysis (PCA) and how does it work? Answer: Principal Component Analysis (PCA) is a dimensionality reduction technique that helps to transform the original features of a dataset into a new set of uncorrelated features called principal components. It works by capturing the maximum variance in the data while reducing the number of dimensions. In other words, PCA identifies the directions of maximum variation in the data and projects the data onto these directions, resulting in a low-dimensional representation of the data that retains most of the information. This makes it easier to visualize and analyze high-dimensional data. What is feature scaling and why is it important in machine learning algorithms? Answer: feature scaling is a process that standardizes or normalizes the range of features in a dataset so that they have similar scales. This is important in machine learning algorithms like KNN and SVM that rely on distance calculations, as it ensures that each feature contributes equally to the calculation. Without feature scaling, features with larger ranges can dominate the calculation, leading to inaccurate results. By scaling features to a common range, feature scaling helps to prevent this and ensures that all features are treated equally, resulting in more accurate predictions. What is one-hot encoding, and how does it convert categorical variables into binary vectors? Answer: one-hot encoding is a technique that transforms categorical variables into binary vectors. It does this by creating separate columns for each unique value in the categorical variable, where each column represents a binary value 0 or 1. For instance, if we have a column with values like red, green, and blue, one-hot encoding would create 3 separate columns: red, 1/0, green, 1/0, and blue, 1/0. This allows us to treat categorical variables as numerical data, making it easier to analyze and process them using machine learning algorithms. What is a hypothesis in machine learning? Answer: in machine learning, a hypothesis is an assumption made by a model about the relationship between input features and the output. This means that the model uses the training data to test and refine this assumption to make accurate predictions. Think of it like a scientific theory, where the model is trying to find the best explanation for the data it has been trained on. The hypothesis is then used to make predictions on new, unseen data. What is the main difference between covariance and correlation, and how do they measure the relationship between two variables? Answer: covariance measures the direction of the relationship between two variables, indicating whether they tend to move together or in opposite directions. On the other hand, correlation measures both the direction and strength of the relationship, providing a value between -1 and 1 that indicates the degree of association. While covariance only considers the direction, correlation takes into account both direction and magnitude, making it a more comprehensive measure of the relationship between two variables. How is feature selection done in machine learning? Answer: feature selection is a process in machine learning where relevant features are chosen from a model to reduce its complexity and enhance its performance. There are three main techniques used for feature selection: filter methods, wrapper methods, and embedded methods. Filter methods use correlation-based filtering to select features, while wrapper methods use algorithms like recursive feature elimination (RFE) to select features. Embedded methods, on the other hand, select features during the model training process, such as in Lasso. By selecting the right features, machine learning models can become more accurate and efficient. What is overfitting, and how can it be avoided in machine learning? Answer: overfitting is a common problem in machine learning where a model becomes too specialized to the training data and fails to generalize well to new, unseen data. This can happen when a model is too complex or has too many parameters, causing it to memorize the training data rather than learning the underlying patterns. To avoid overfitting, several techniques can be used. One approach is to use cross-validation, which involves splitting the data into training and testing sets and evaluating the model's performance on the testing set. Another approach is to apply regularization techniques, such as Lowen or L2 regularization, which help to reduce the complexity of the model by adding a penalty term to the loss function. Finally, simplifying the model or reducing the number of features can also help to avoid overfitting. By using these techniques, machine learning models can be trained to generalize well to new data and avoid overfitting. What is underfitting, and how can it be identified? Answer: underfitting occurs when a machine learning model is too simple and fails to capture the patterns in the data. This can be identified by checking the training and test errors, which are both high. In other words, the model is not able to generalize well to new, unseen data. To identify underfitting, you can look at the performance of the model on both the training and test datasets. If the errors are high for both, it may indicate that the model is underfitting. To overcome underfitting, you can try increasing the complexity of the model or adding more features to the data. This can help the model to better capture the patterns in the data and improve its performance. How do you evaluate a machine learning model? Answer: to evaluate a machine learning model, you can use various methods depending on the type of problem and model. For classification models, common evaluation metrics include accuracy, precision, recall, and phone score. For regression models, mean squared error (MSE) is often used. Additionally, cross-validation is a technique used to assess the generalizability of the model by training and testing it on different subsets of the data. This helps to avoid overfitting and provides a more accurate estimate of the model's performance on unseen data. By using a combination of these methods, you can get a comprehensive understanding of your model's performance and identify areas for improvement. What is the bias-variance trade-off in machine learning, and how does it affect the performance of a model? Answer: the bias-variance trade-off is a fundamental concept in machine learning that refers to the balance between two types of errors that a model can make. Bias refers to the error caused by a model being too simple and failing to capture the underlying relationships in the data, resulting in a consistent but inaccurate prediction. On the other hand, variance refers to the error caused by a model being too complex and overfitting the training data, resulting in poor performance on new, unseen data. The goal of machine learning is to find a model that strikes a balance between these two types of errors, minimizing both bias and variance to ensure good performance on both training and unseen data. This balance is crucial, as a model that is too simple may not capture the underlying patterns in the data, while a model that is too complex may overfit the data and perform poorly on new data. By understanding the bias-variance trade-off, machine learning practitioners can develop models that are more accurate and robust. What are hyperparameters, and how do you tune them? Answer: hyperparameters are settings used to control the learning process in machine learning models, such as the learning rate or the number of trees in a random forest. They are different from parameters, which are learned during training. Hyperparameter tuning involves finding the best combination of hyperparameters to use, which can be done using methods like grid search or random search. This process helps to optimize the performance of the model and improve its accuracy. What are grid search and random search, and how do they differ in hyperparameter tuning? Answer: grid search is a method of hyperparameter tuning where all possible combinations of hyperparameters within a predefined range are tested. This means that every possible combination of hyperparameters is tried, which can be time-consuming and computationally expensive. On the other hand, random search is a method where a random set of combinations of hyperparameters is tested. This approach is faster and can be more efficient, especially when the search space is large. The main difference between the two methods is that grid search tries all possible combinations, while random search tries a random subset of combinations. Grid search is more exhaustive, but random search is more efficient. What is gradient descent, and how does it work? Answer: gradient descent is an optimization algorithm used to minimize a model's cost function. It works by updating the model's parameters in the direction that reduces the error based on the gradient slope of the cost function. The algorithm starts with an initial set of parameters and iteratively adjusts them to find the optimal values that minimize the cost function. The process continues until the algorithm converges or reaches a stopping criterion, such as a maximum number of iterations. By following the negative gradient, the algorithm moves in the direction that reduces the error, allowing it to find the optimal parameters that minimize the cost function. This process is repeated until the algorithm converges, resulting in the optimal model parameters that minimize the cost function. What is stochastic gradient descent? Answer: stochastic gradient descent (SGD) is a type of gradient descent where the model updates its parameters using a single or small batch of data points, rather than the entire dataset. This approach speeds up the optimization process, but it may result in more fluctuations in the parameter updates compared to traditional gradient descent. SGD is often used in machine learning to train models quickly and efficiently. What is mini-batch gradient descent, and how does it balance the benefits of standard and stochastic gradient descent? Answer: mini-batch gradient descent is an optimization algorithm that combines the benefits of standard gradient descent and stochastic gradient descent. It updates the model parameters by using a small batch of data points, typically ranging from 1 to 100. This approach balances the stability of full-batch gradient descent, which uses the entire dataset to update the parameters, and the speed of stochastic gradient descent, which uses a single data point to update the parameters. By using a small batch of data points, mini-batch gradient descent can converge faster than standard gradient descent, while still being more stable than stochastic gradient descent. This makes it a popular choice for training machine learning models. What is regularization, and why is it used in machine learning models? Answer: regularization is a technique used in machine learning to prevent overfitting by adding a penalty to the model's cost function. This penalty discourages the model from becoming too complex by having too many parameters. The goal is to find a balance between the model's ability to fit the training data and its ability to generalize to new, unseen data. Regularization helps to prevent the model from memorizing the training data and instead encourages it to learn more generalizable patterns. This is especially important when the training data is limited or noisy. There are different types of regularization, such as lone lasso and L-tour ridge regularization, which can be used depending on the specific problem and data. What is the primary difference between lone and L-tour regularization techniques in machine learning, and how do they affect the model's behavior? Answer: the primary difference between loan and L2 regularization is the way they penalize the model's weights. Loan regularization, also known as lasso, adds the absolute value of the weights as a penalty, which can lead to sparse models where some coefficients become zero. On the other hand, L2 regularization, also known as ridge, adds the square value of the weights, shrinking them but not setting them to zero. This helps reduce overfitting by penalizing complex models, but it does not set any weights to zero. As a result, loan regularization tends to produce more sparse models, while L2 regularization tends to produce more complex models that are less prone to overfitting. What is a cost function? Answer: a cost function is a mathematical formula that measures the difference between the predictions made by a model and the actual values. It is used to guide the optimization process during training, aiming to minimize this difference error by adjusting the model's parameters. In other words, the cost function helps the model learn from its mistakes and improve its accuracy over time.